These are the machine code bytes of a short program. DB04 is machine code for load the accumulator with input from port 4. D304 is display what's in the accumulator on output port 04. And C30008 is jump to location 0800, which is the beginning of the program, so it'll loop around. Basically, it just takes whatever input is on the port 4 switches and puts it on the port 4 LEDs to display. So we'll run the program using the run command. And if you look at the computer now, when I change the switches on port 4, the LEDs light or go off correspondingly. Now the single step clock is run by these two switches hooked up to a bounceless toggle, basically a flip-flop that just sets the clock low and high. Now this particular Z80 that I have in the computer by Toshiba is one of the ones that does this very well. There's also a Z-Log Z80 part that also does this very well. Most Z80s will single step, but you can't leave the clock on low. If you leave it on low, some Z80s will get unstable and you'll see the lights start to come on and then the Z80 will lock up. However, the Toshiba Z80 that I'm using here is stable whether the clock is low or high. There are informations and part numbers in the instruction manual for the bus display, so if you want to get a Z80 that works really well in single stepping, you can see those part numbers. So now if we'll just go through the instruction and wait till the M1 light comes off. There. So this is M1, and this is the beginning of a machine cycle. And right here, the address displays 0800. So it's the machine cycle that is going to execute the first instruction in the program, which is, we saw before, DB04. So it's going to first fetch the operation code, which is DB, and then it's going to go through a refresh cycle. Then it's going to fetch the address 04, and then it's going to perform the instruction and bring whatever data is on port 04 into the accumulator. We'll see all those steps as we go through this. So the first thing that happens is it's going to fetch the instruction. So as we cycle through, the memory request and read lights will come off, meaning it's reading from memory, and you'll see the first byte of the instruction, DB, appear on the data bus. There, DB. So this is now read into the processor's accumulator, the A register. It's read into the instruction register rather, and now the processor will interpret the instruction and perform it. The next couple of clicks is the refresh cycle. Now the refresh cycle is performed while the Z80 is interpreting the instruction it got, so there's really no waste of time or energy. The refresh cycle is for systems that have dynamic memory that need to be boosted every millisecond or so. These are memories that are made essentially with small capacitors that will leak if they're not refreshed. And the refresh cycle is characterized by the memory request lamp going out all by itself. The write and the read LEDs are both on, showing they're inactive. In addition to the memory request going low, there is a refresh signal also put out by the Z80, not shown here, that is used to refresh these dynamic memories. And the third part is there's a row address placed on the address bus during the refresh cycle to tell which row of memory to refresh. So let's go to the next cycle. Okay, now what's going to happen is the instructions in the Z80 instruction register, it's being interpreted, and now the Z80 is going to fetch the next byte of the instruction, which is the port address. Port address is located at 0801. So it's put the address here. Now a down click, and you see the memory request and the read lamps are off, meaning it's requesting the memory to put the byte at 0801 onto the address bus, and it's there, 04. And now with another click, it reads this byte into its instruction register, and now it has the whole instruction. So as we go through, the next thing it's going to do is perform the instruction, which is an input-output read. So now the input-output request light is off and the read light is off, meaning it's taking whatever is on these switches, putting it on the data bus and into the accumulator or the A register of the Z80. So here it is, and it's being taken into the Z80. So after that takes place, we're going back to M1 for the next instruction. Remember, the next instruction is to place whatever's in the accumulator onto the output port. So first it's going to get the instruction, which is D3. Then it's going to go through its refresh, as you can see. Now it's going to get the second byte of the instruction, which is the port address, 04. Now it's going to interpret that and place the data from the accumulator onto the output, onto the data bus and to the output port. So there it is. That's the byte that we've seen before and being placed on there. And you have the input-output request and write lamps being low, meaning the processor is signaling this port to write the data of the data bus onto the LEDs. And then after that's finished, we go back to M1, which is the next instruction. Now this is going to be a jump instruction. So it's C3, that's the jump instruction. And then we do the memory refresh. And the address comes next, which is 00, 08. And now it's going to do the jump. It's done the jump actually. Put that address into its program counter, and you can see it there. 0800, M1 is low, so it's going back to the beginning of the program loop, and it'll perform all these steps again. This concludes the demonstration of the bus display for the CPUville Z80 single board computer. If you want to know more about it, check the CPUville website, and the instruction manual there has details and schematics that you can look at. This is Don Stewart. Thanks for watching.